Okay, hello. Are we in? I think we're in. Cool. Hi, hello, welcome. I may or may not be streaming. I think I'm streaming. Okay. Hello. Yes, welcome to this, which may be the first and or last video of a series that I believe will be called Hacking Ultra Skelly, wherein we discover if we can um, find a way to hack apart this 6.5 foot tall animatronic skeleton decoration that I bought from Home Depot and build in some connection to a large language model, which I can then prompt up with our documentation and sort of various other instructions to make this fine fellow into a standalone automated Skelly information delivery system. And yeah, the plan is so Free Mocap is going to host a vendor booth in the nonprofit section at the 2025 meeting of the Society for Neuroscience in San Diego in mid-November. And for those of you who don't know, we are entering spooky season here in America, which is also corresponds to the time of year where Home Depot sells its skeleton decorations. Famously, they have a 12-foot tall skeleton, which I have long dreamed of purchasing and putting in our vendor booth. But problem is that it's hard. San Diego is far away, and also technically the rules are you're not supposed to have anything over 8 feet. So this guy was 6.5 feet, and I think it's hackable. So we're gonna see. So today on this stream, I'm going to unbox this bad boy, see what we've got going in here, and kind of see just planning out is it actually feasible to do? I think it might be. I think it might be. We'll see. And if it is, then we could sort of take it from there. The idea would be to probably lobotomize it and take out its whatever control system it has, which is this sort of app-based thing, and hijack its sensors and its outputs, run it through probably an Arduino, but like a ESP32 or a Raspberry Pi or something like that, and then just hijack it so that it can do what I want it to do rather than sort of what this app does. It's possible that this app will have sufficient interface, and the general thing will be one of the things we'll figure out is how it's set up and how much I'll have to remove versus how much I'll be able to use what they have already set up. But we won't know until we open it up, and I suspect that we'll probably wind up just snipping the wires to whatever their control system is and then just hooking it up to our own thing and then controlling it directly. But yeah, we'll see. I sure hope I'm streaming. I'm pretty sure I'm streaming. I guess I could be recording too. Let me check real quick. Let me go back to this regular thing. I will double check that I'm streaming before I get sad about that. I'm not on my normal. I don't need to go to Twitch, do I? Nope. Also, if it's not good, I will not be able to see chat windows and whatnot while I'm doing this. So that should be me, right? Huh? I believe that's me. Oh yeah, there you go. I also should be now double streaming on YouTube, which I think it's not hard to do the dual streaming thing. I think I guess we'll find out. And I do think that you can do YouTube without the commercials, so we will see how that goes. What are you doing? Oh. I'm not logged in on this computer, so we see if I can just find it remotely. Yeah, look, there's me. I'm live now. Great. Cool. We're in. We're doing it. Let's get into it. Okay. And that scenes now, you see. So yeah, they got PMP, got this little guy here. Let's take a look. Let's start by taking a look at what we're working with. As always, this is Pooh. Say hello, Pooh. She will be assisting today. Okay, so let's take a look at what we're working with. So that's Skelly. And 6.5 foot, graven bones. I don't really know what that means. I don't think there's a thing. Animated, animatronic, LED app control. I don't know why LED is tech. I think it's just a name. They're not saying. It's weird to see LED with a registered trademark, whatever. Ultra Skelly, which is a reference to the 12-foot tall one. I think is literally called Skelly, which I love. With life eyes, LCD eyes. Yeah, so got some glare there. No, got a lot of glare there. Yeah, so those eyes are just little LCD screens. And so yeah, got a timer, in control, torso, arms, mouth movements. It's got recordings and speak through the character in live mode, which I assume means that there might be a microphone. I don't know if it's a two-way thing. Might have to put our own microphone in there. Blah, blah, blah. It's got the app. You can control stuff. Got colored LEDs, and you can sort of put stuff into the LCD screen. This is the kind of... I expect that all of this will be closed up to the point that I'll have to rewrite my own sort of version of the controller if we sort of get that far. But we'll see. Based partially on that information and also like what I saw in the store, I believe that it's going to have servos. So yeah, torso, arm, and mouth. So one servo, 1, 2, 3, 4, I think 5, and then 6 right here. So it's going to have 6 total servos that'll be controlling stuff through some kind of a pattern. And these guys right here are LCD screens, so little LCD screens, which, you know, that's another thing that depending on how that's set up, it may or it, you know, we'll see how hard that is to interface with. We might also like put a camera in here, like maybe hide it in the nose or something like that, so we can do some vision-based stuff, which would be pretty cool. There's some kind of internal LED system, so probably just a couple RGB LEDs that kind of cycle through. And then this thing right here is a proximity sensor. That little dot right there, that's a proximity sensor. So that's how it, I think that's how it like triggers turning on, like when someone walks close. So yeah, okay, let's crack it open. All right. And let's switch over back to this. Yeah, that works. Let's make it taller. Ooh. Okay. How's everybody doing, I suppose? I don't know. I guess I can't see the chat, so I won't ask. But if there is anybody there and they're watching, I hope they're having a good time and a good day. They're as excited about this as I am. All right. Yeah. So. Too small. Great. All right, let's crack this. Let's see what we got here. Mostly what I'm going to be doing is trying to find the sensors and trying to just get a general sense of like how it's set up and what would I guess the interface be, like where would we start trying to sort of like hijack the IO. Okay, we got, yeah, so there's an app-based operation and setup thing. Oh, this is just, these are app instructions, whatever. And then this is sort of putting it together, which we may need, but yeah. And also, just to be clear, I will be sort of documenting this. If it seems like something that's doable, I will be documenting it on sort of live streams and then sort of edited videos. Maybe I may not edit it. And whatever I figure out, I will also document on GitHub. So if it is a feasible thing to do, you will be certainly invited to join and contribute. And I guess the most people would want the goal to be to get it something functional before Halloween, which would make sense. But for me, the conference is on November 14th. So that's my deadline to have something viable here. But we'll see. Okay. I guess I gotta keep this box intact as much as possible. And I guess this will help me put it back together if I need to, because I might have to sort of pack this up and ship it across the country. Cool that it's using, ooh, I was expecting to see like big blocks of styrofoam, so I'm glad that I'm not seeing that. It's just kind of cleverly oriented. Great. Alrighty, let's see what we've got. And again, I guess I'll have the video, so if I need to try to put it back together and it's difficult, I can refer to that. So, hey man, calm down. This is what they're doing to us. The disrespect is the worst part for me. Okay, so the hands are articulated, but they are not powered. The wrist also is not powered. This appears to be connected to a gearing mechanism of some kind. Interesting. So my goal for this this iteration, I might take it apart depending on based on what we find, but I think right now it makes the most sense to just focus on the fact finding, and we can come back to it at a later date. It's also the end of the day, so I don't necessarily want to stream forever. And yeah, so we'll see. Yeah, minimally my plan is to spray paint this to free mocap colors and sort of I bring it along because why the hell not? But yeah, let's see how this guy is articulated. Okay, so we've got this kind of hexagonal port at the shoulder, which appears to be static. It's, oh, these are not articulated. They're just rigid. Okay, so it articulates at the shoulder, so it's going to be 4 servos, not 6. So that makes sense. That makes sense. Maybe at a future date we could. Actually, that would be fun as. Oh. No. Okay. I could keep going and just act like these are not articulated, but they are articulable. So you could imagine all sorts of things, like just building additional servos, building additional control systems into here, mapping it to free mocap recordings. No. Okay, let's not get ahead of ourselves. Okay, so we've already discovered one thing, which is that the articulation is going to be at the shoulder point. So, which the arms are not articulated; they're fixed. So that's one piece of info, which means that most of the motoring is going to happen, I guess. Well, I see. Torso and pelvis, I'm guessing. Also, which I'm cheating because I'm currently looking at them. Okay, so I guess in terms of like this, like the anatomy of it, it's okay. Shoulders aren't that great. Like in terms of like the realisticness of the anatomy. I don't know what this line is. I don't think that's a real thing. Um, Same material between the sternum and the ribs, and you know, it's not that bad. It's not the worst I've seen in terms of like sort of skeleton, sort of pop-size skeletons. It's not clear. One of my hobbies is critiquing sort of like things like skeletons and brains, depictions of skeletons and brains that I've seen that come across in popular culture. Okay, these are, oh, that's lower leg. That's knee, so femur and knee. Ooh. And then this, of course, is the torso. And so immediately, ooh, this is cool. We're seeing some of the guts, as they say. So this is that. It's not hexagonal. It's some other shape. Yeah, it's like a cube with a cut, like a square with a cut corner. And then connected to the inside of that is some pretty significant looking gearing mechanism. Get in here, you. Yeah, there it is. So yeah, I've seen this kind of thing before. Like Jesus. First of all, let us switch over, and then let us pull that in there. Yeah. So if I were to sort of, I like to listen. I take apart electronics and toys. It's fun to do. I recommend it. You learn a lot about just design and mechanics and whatnot. But I've seen this type of stuff a lot, and if I were to crack it open, I am quite confident that I would find a motor right here, like a little DC motor. And then this is going to be like all, this thing is a gearbox. So this thing right here spins, and then this thing right here cranks, which makes sense because it's moving a limb. And one of the most notable things about limbed robots is that they are always operating at a tremendous mechanical disadvantage. It is the worst possible way to move a long limb. Like if you want to move a column, moving it from the point of rotation is the mechanically least advantaged way to do it. You would prefer to move it out here, but of course muscles don't work that way. So it makes sense that for this animatronic bad boy, at those joints in particular, you're going to have a lot of gearing to get the kind of power that you would need to actually articulate it. I will be curious actually to see if there's a similar thing at the neck and the pelvis, because the sort of like the way the mechanics work, rotating those parts, like the torso will be more like, the torso will be the heaviest because it's the torso, the arms, and the head. But rotating the head around the cervical spine actually shouldn't be. Oh, that's the bottom. Wait, where am I? Yes, the bottom. I don't know. We'll see. Let's keep going. Okay. So, okay, interesting. So, let's get back in there, doctor. Okay. So on the right shoulder, we have this gearing mechanism. On the left shoulder, we have this whole box. And, oh, this one has a hexagon on it. The one I saw before. You can see these plugs here that I don't know if you can see them, but like these plugs are all over. They're clearly, this is how they do their data transfer. So you can see that in here. And then I guess now that I'm looking at it, you got this other guy running across here that's controlling this thing. So only one wire coming in and out of this gearing mechanism, which is a good sign. Presumably, oh, and then I'm feeling this on the back here. Nice. That, oh boy. So on the front of the sternum, you got this thing, which is clearly a speaker, and then you've got this thing, which appears to be an LED, but I guess we'll figure that out. I'm also seeing screws all over it, which is good because it'll mean it should be pretty easy to take apart. And now we are also seeing the reason for the box at the, what is that, left shoulder? I may have said that opposite before, but this is the left shoulder, and this is probably the brain. And is that what I want? No, I do want that. Swap back over. Yeah, sure. Why not? Okay, so looking at this, it's got Bluetooth, lights, step pad, timer sensor, whatever the hell that is. Ming Heng, thank you for your work. Step pad. I wonder what that means. Step pad? I have to look that up. Mode. Let's see, demo mode. FCC ID. Got a model. I wonder if I could look up part numbers and stuff like that. I wonder how much of that is public. Probably not very much. Microphone. This is a really strange feeling button. Got to click to it. And then, yeah, what is this? What's that? Step pad. So I've been saying servos, but these also might be stepper motors, which is like what a 3D printer uses. I'm not like 100% sure about the difference between, where am I looking? Am I looking here? I'm looking here. I'm looking here. I'm looking here. I'm looking everywhere. I am not 100% certain about the difference between a servo and a stepper motor, but step pad, like I'm wondering, because this is a plug, and I'm wondering if like it's possible that this is going to be the thing that we can kind of like tap into. Like I would love to use as much of this machinery as intact as possible. So if they did in fact give us a nice and easy way to interact with that, then that would be great. And I would say some kind things about old Ming Heng, whoever he is, whoever they are. I'm guessing it's probably a what's the word, like a manufacturing factory. So I'm trying to look up where they talk about the step pad, if anywhere. Assembly instructions. Okay. Step pad. This switch mode allows the item to be activated only if triggered by a step pad or the but step pad, like you step on it. I see. Like a pressure sensor. Interesting. So that would just be, that's probably just like a toggle. It's probably like a step, like step in the sense of like you hook it up to something, you can step on it, and then when you step on it, it triggers a thing. So, you know, so then that's probably not useful to us, but we can, it's again another thing we could hack if we wanted to. Okay, we got the power block here, and I was seeing if they gave us any additional stuff. Okay, so the brain is in the torso, obviously. If you weren't aware of that, consider it here. I am in fact a expert, scientific domain expert, and I am here to tell you the brain is in. Your brain is primarily behind your left shoulder blade. Okay. Cool. But yeah, it seems nicely take apartable. You know, it seems like it's mostly held together with big visible screws and not instead and not a bunch of like sort of like glue and stuff, like hidden stuff. So and all the main parts and pieces, like this big stepper motor in there, also seem like they're held in place with like big visible screws. So like, for example, I'm pretty sure I could just sort of like unscrew these guys around the ribs. Um, let's switch back. Okay. So yeah, if I unscrewed like these guys through the ribs, I think I would get pretty easy access to the shoulders and also there's okay, so there's some stuff on the breastplate, which is not surprising. Oh, this is the, can you see this? Let's see. This right here is the other side of this motion sensor. One in is, I think, the LED, and then this bad boy here appears to be the speaker. And that's it. So, cool. Torso explored. Now let's look at my favorite osteological structure within the human body. You might think it's the skull. You might think it's the skull, but you would be wrong. It is, in fact, the pelvis. So, this is also tends to be the place where the scientific reality tends to break down. But this isn't bad. It's like really tilted forward in a weird way. These obviously should be voids, but that's not surprising. The ASIS, or this is weird. This is, I don't know. It's oriented weird. It's sort of acceptable. This is actually kind of a little more Australopithecine, if you know what I'm saying. Whatever, you know, we take what we can get. We got these cables running through. Where am I switching over again? Let's switch over. Got these little cables running through. There's so this is a 2-pin, and this is a 4-pin. These are male. So see what that does. This is the power jack. It seems like things are also set up to be waterproof, which makes sense because it's meant to be held outdoors. So like the plug has a screw bits on it, so you know that's nice. Yeah, again, we got these pretty easy accessible screws so that we can take it apart if we need to, and then it seems like the frame appears to be the same kind of like sort of like pressed square, whatever this name is, that I would assume is pretty sturdy. The whole thing is like, it's not like super heavy. It's kind of heavy, maybe, I don't know, 30, 40 pounds in the box. I don't know if that's correct. I don't really have a good sense of that. What is that, 20 kilograms? Okay. So not a lot going on in the pelvis. It's got the power plug, but that's it. So mostly, oh, these must, well, I was gonna say they must be sending power, but like this one's got the 4 pins, and I'm not sure where that would be going to. I don't know why there would be 2 things. I guess it's different routes for the power. Mapping this out, I guess, will be part of the fun. Okay. Now, much as I love a good pelvis, now it's time for the crowd pleaser, which is, of course, the skill. All right. Also, the feet, I have, you know, these are fine. You know, obviously the ankles are bonkers, but that's to be expected. I also have a soft spot for feet, not in that way, just because my undergraduate, postdoctoral, and sort of presumed future research is so heavily emphasizing locomotion. So I know a lot about like the physiology and evolutionary history of like the foot bones, and they are, it's like one of those things. I think that they're just like they're underappreciated in their complexity. Like your feet are like anatomically very similar and just as complex as your hands, and they are very active, but they're tuned towards like force control versus like manipulation. So, anyways, whole other conversation. Okay, we can only assume, dear friends, that this contains the man himself, Ultra Skelly. Actually, no, this is, I don't even know if this is anatomically correct enough to make any judgment calls about the likelihood of male or female progeny. Always tricky to estimate that, but almost every skeleton I've ever seen, and by almost I mean I'm just saying that because I might be forgetting something, but every skeleton model I've ever seen that I've been aware of has been a male skeleton, meaning that sort of stereotypically male skeleton, like pelvis specifically. Neither here nor there. Here we are. Oh, okay. Skull. Skull. Can I take this whole thing away? I guess. Yeah, not going to bother. And wonder actually, because I'm pretty sure most of the brains are going to be in that shoulder, but it's possible that there's going to be something interesting going on in the head, because it's got those LED screens in it. And as we know, video and its opposite friend, displays, where a lot of the difficulty comes in. So, skull-wise, pretty good skull. I like that it's not like angry skull. I don't like Skelly, the Skelly logo. We did a lot of work, a lot of design planning went into like trying to make a friendly looking skull, and a lot of Halloween stuff in particular. They changed the skull to be to make it like scarier looking by giving it like a furrowed brow or like sort of more demonic looking teeth. But this looks like honestly a fairly anatomically accurate enough for the sort of production value kind of skeleton, kind of skull. So appreciate that. So yeah, there you go. And I think he looks nice. What's up, buddy? I'm gonna move this. Feet are falling asleep. Okay. Oof. My feet is asleep. So, all right. Okay, let's take a look here. And this one? Nope. That one. So, okay. So looking at this guy, we've got 3 ports going in. The beige, the red, both are female 4-port. And then this white male 4 pin. We've got another, this appears to be the same kind of LED that was on the inside of the sternum, but it's asleep. We have again kind of some kind of actuation in the jaw that feels spring loaded, which probably means that there's something in, sorry, I move in a place that will allow my feet to wake up. So yeah, so it's got kind of a springiness to it, which is probably how they get around, but I'm assuming it's a pretty slow mechanism. in those servos or steppers, whatever it is that they wind up being. And then of course we got the, where are we looking? Here? No, here. LED screens in there. So I would assume on the inside here that it's got a similar kind of gearing mechanism. Wait, did I not have? It had a similar kind of gearing mechanism to what was in the shoulders. But it might have kind of like a, what do they call, like a nautilus gear, or like a helical gear or something like that, where I'm guessing it can crank, and then when it gets to a certain point, like it pulls, and then it drops it. So I'm guessing that that's kind of how that works. There's going to be something on the inside that's got some kind of, yeah, like a helical. Is it helical? It's like a nautilus shell. So it's like part of a spiral and then a drop. And I'm guessing that it sort of flips around and does something like that, because, or it could be wrong. What do I know? Little to nothing. Oh, I also, so this has got this sort of like notched pin thing, which is probably also connected to a motor on the inside. And that probably controls the head rotation, which would make sense because, yeah, because we're seeing this notched pin at the top of the spine. Okay, what I am not seeing is a way for the torso to rotate. So, and I'm pretty sure it said that it did. So, because we found the two motors in the shoulders, we got one motor now in the skull, and I didn't see anything in the hip, but, oh no, yeah, okay. Yeah. There is another motor in there, so it does rotate around there. That looks like that looks like an interesting, well, it's probably the same as the shoulders, would be my guess. Cool. Cool. Okay. Okay. So yeah, and then that would make, so then we've seen a couple different colors of plug, like there's different routes of wiring. This yellow, like this two pin male yellow, 4-pin male. Oh, this is probably going to come back down from the motor controller in the shoulder to control the rotation at this sacral joint. This is the sacrum, S2. Right, so it's probably power comes up from pelvis at this sort of plug right there, goes up to this control box, maybe? No, maybe I'm wrong. Maybe that's not a control box. Maybe this actually, I might be wrong again. I often am. This may not be the brain. This may just be sort of like a control, like, you know, plugs and sensors and stuff like that, because it's looking like the brain might be in the head, big if true, because yeah, it looks like the power comes up from the hip through either, probably through the yellow, because it's just the two pins, so that's probably power, and the 4 pins are probably control, so that would be positive, like power. So the 4 pins would be probably power, ground, turn left, turn right. I mean, yeah, because the only thing because this, yeah, anyways, so power up comes in through no, again, oh, I guess, right, you wouldn't be able to see that necessarily. I'd have to take it apart to actually see, but there's not a 2-pin coming out of the neck. It's four pins, 2 male, 1 female, which would mean that this power cord probably does just go to this block. And then, yeah, and I'm now seeing kind of the, there's like, you can see there's like the beige wiring that's running through. Oh. Okay. Yeah, to these front pieces. So to control the speaker, the light, and then the proximity sensor. Cool. Okay, how we are? Where are we at? We're about 40 minutes in. I'm not going to be able to take this whole guy apart, but I think I'll take just the skull. I think I'll take the skull apart, and then we can call that about a day. All right, so how are we going to do that? Interim check-in. Everything that I'm seeing makes me think that this is doable. The sort of interfaces, like the wires are pretty simple. The motors are pretty sort of exposed. The mechanism, at least, seems pretty obvious. I think it seems like things like figuring out how to do the LCD screens or whatever, like that can be tricky. But I at least know that I'll be able to, or that I could conceivably tap into the wires coming out of these motor mechanisms and control those. And presumably, like tapping into a speaker should be doable, because the goal, we're thinking about, can we put AI into this machine? And you got the speaker. So if you have, and then there's no obvious microphone, which is not surprising, but I can add my own microphone and then have it connect via API to something that has the ability to take, so it needs speech to text. So the human speaks, the AI transcribes, send that into some form of like agentic AI, just simple prompting would be fine. And then have that sort of, I mean, I guess the old school way to do it is record the voice, transcribe it to text, put that into a text-based LLM, take the text from the output and convert it into audio with a text-to-speech mechanism, and then just play that out the speaker. But these days, I'm pretty sure there's a lot of things already set up that's kind of like audio to audio is a more like direct route. So I don't think I have to do those secondary steps, which just makes it that much easier. And then if I wanted to, I could also just like attach a camera, like stick a camera, like hide a camera in there, and then feed that through some kind of a vision model, and then it would be able to like know you're there, and like describe what you're wearing and stuff like that. And then could use this proximity center to trigger it. I wouldn't want to put the trigger on the, like I would want a lower level mechanism to determine like presence of the person, and then say, hey, okay, AI bot turn on, and then it can start feeding from the camera. But yeah, I don't know. And I was also thinking I could put like a screen in the belly so that you can sort of get it both controls and kind of like, debug terminal plots. I like that as a sort of mechanism. I wouldn't want to have this thing just kind of like sitting out, not explaining itself. I would want it to be, what it is, but also like sort of show the sparking wires in terms of like the terminal logs and stuff that would be streaming by. And that's easy enough to imagine, at least. Okay, let us take apart this guy. Let's see what we got going in there. What do you say? What do you say, friends? Okay. And let's switch back over. Boink. Let's turn that a bit. And let's... Okay. All right. Okay, Skelly. Let's see what you got. Let's see what you got. Well, okay. First of all, I grabbed the wrong screwdrivers. One moment, please. You probably still hear me. It depends on the range of this mic. That should do it. All right. So unsurprisingly, these are, I think, well, I guess we'll find out. All Phillips head. This may not be long enough. One moment. Sorry, friends. Probably still can hear me again. Oh, alrighty. Where's the right screwdriver? There you go. It should work. So I guess that's the same length, isn't it? Okay, that'll be. Thanks for holding it down, Pooh. All right. If we can't do it with this, then we can't do it tonight. So, are we all the same length? Okie dokie. Skull. Let's see. 1, 2, 3, 4, 5, 6, 7 screws. Inexplicable L. Wait, what are we doing? Right here. Strange L for some reason. There's this kind of bag thing, which I'm wondering if this might be for water protection or something like that. Oh, this is probably a water. Probably the main brain of this of the LCDs are in here. All right, let's get going. So, are those? Yeah, those are Phillips. Okay, I think there's the Phillips, and I think it needs a longer, bigger guy, so to speak. Okay, cool. Thanks, Pooh. All right. This was not a precision screwdriver situation. It was a more regular type. And here we go. All right, there we go. Okay. And this little magnet thing to store to hold on to the screws. Oh yeah, there you go. Yep, little machine screw. We got 1, 2. Glad these are small. They could have just as easily been like huge. Which would have just been annoying. Okay. Bless you. 1, 2, 3. Four. 5. Brain surgery, you see. Just like this, pretty easy. Problem is with humans, you got like the hair that gets in the way of the screws. But, you know, nothing a little elbow grease can't handle. Come on now. Oh, I wonder if those are different because they're on the neck. Okay. All right. I would assume if there's any warranty, I have now avoided it. Ooh, okay. All right, so let's not lose these last two. Oh, okay. Oh, okay. Okay. Ah, there we are. Okay, so we've got this split across the two halves. This is on the occipital side, the back of the head, which has, oh, interesting. I love cracking into these mechanisms. They're always something, they're always so interesting. There's always something so cool going on that you just like would never expect to find in like a really simple, wow. Whoa. Okay, how can I show you this? I love this. Okay, so let's start from this side. Let's turn on this little light. It needs to be so red. I don't think it needs to be so yellow. There you go. So this is the back of the head, and we've got, first of all, just look at this cool thing. I guess this is just a way to transfer the rotation. I'm just gonna go, can I do this? Oh, I can't do that. I can do that. Oop, not that, other way. That, thanks. So this is the cool, so this is that notched sort of whatever it is, stick thing that we saw. And then it's got this sort of crazy mechanism here. There's a name for this, but I don't know what it is. But this is, I think, just a way to transfer the rotation through this kind of like weird joint. So that is a servo. And I think so is that. So 1, 2, yeah, these are 3 servos. And these are standard ass servos right here, I tell you. Like there's nothing so they're attached to this interesting block. And I guess, it's, I was wrong. This is a slider joint. This slides back and forth, and I guess maybe side to side too, because that would explain the axes that we're seeing. So this one, I think, is the rotating axis, and then this moves, and I'm guessing that it moves sort of like this is controlling one axis and then that's controlling the other axis. So yeah, this is a 6-axis controller right here. That's awesome. Man, I want to take that apart. This is also the place where it's like my desire to take it apart may cut against the desire to maintain it as a functional object, but we'll just have to see. Cool. Yeah, and then like these are like these servos. I mean, that's just the 3-pin. I mean, these are like they're attached to an interesting gearing mechanism, but they themselves are. This is like I got like a box of these things that are like almost exactly that. So yeah, so that's can't do it that way. Can't do it that way. I don't know if it moves side to side. I don't think it does. Looking closer at it, but I also maybe it rotates. Oh, it does rotate. No, that's that rotation. And there's that. Yeah, these black ones are fixed. So I don't know why there's 2 of them. Maybe that's just for power. I don't know, because I mean they're pretty small. Like these are pretty small servos. So, or maybe it's for the no, because okay. So, all right, let's move over to the front of the head. So orienting you, that's the face. And so then we've got eyeball, And then this is the mouth. This is that rotor mechanism that I predicted. That's the spring loading of it. And that's the spring load. This is probably another work on my cinematography if I'm going to keep doing this. Oh, I really don't want to damage it. Okay. Yeah. Yeah, so this is, you can see there's another gearing mechanism here, which, yeah, has this, like some kind of stopper mechanism right there. And then you can see the eyes as well. In there, you've got there's this 4-channel ribbon wire going in to one of them, and then they are connected through this sort of like video sending thing. I recognize this from Arduino stuff. Says 60V 80C. Seems hackable. Again, seems accessible. And now the hardest part to understand, and possibly the part that I'm not going to be able to maintain, is this thing right up here. So this, what is that, a relay? What do you call that? I don't know. But let's see. So we got these plugs coming in. There's some pretty sloppy hot glue sort of all over this, which is not shocking. This is sort of what I am used to seeing in stuff like this. But it's interesting because it's clearly expandable. Like whatever it is going on here, there's like the big bus here, which is 1, 2, 3, 4, 5, 6, 7, 8 wires, which is either input or output. Oh, that's input or out. Well, that's what these things are connected to. Well, some of them are connected here. Some of their red light. Yeah. Anyway, we can figure this out. And then you got these big capacitors here, not that big. And you got some little. This might be video. I don't know. A lot of this is beyond me. And then you got this guy here, and you've got this sort of weird capacitor built into it. But I think I can take this into, there's like a makerspace near me, and I should have mentioned before, a lot of my sort of hypothetical capacity to do this is contingent on taking it into that makerspace and asking them desperately to help me do it, because I personally couldn't, but I know the people in there could. There's like proper electricians and engineers and sort of roboticists in that group. Okay. Where are we at there? That is an hour. That's exactly an hour. That's a great time. It's a great amount of time to stream. And now I think I will attempt to put this guy back together. And yeah, call it good. Okay, so I didn't really see that much by way of waterproofing, now that I think about it, around like the main seam of the head. So actually, I mean, I guess it's probably fine, but I don't know. I wouldn't trust it in a rainstorm if I cared about it. Okay, put you back in. Okay, so I'm gonna, yeah, I will do this guy back in, and then I'll end the stream with what's the word? retrospective, prospective. Pretty sure I didn't break it. I guess I should set it up at some point, see how it actually runs rather than just like immediately taking it apart. But you know, that's not how we always like to do. Okay. Okay, that's. I don't need to screw them all the way down, just enough that they're sort of tended to. Yep. And if they don't do that, cool. Okay, Skelly. Overall, it seems doable. It's not a small project. It's not like a thing I can do in an afternoon. It would require a careful approach. Like I'd have to like plan it out and sort of try to figure out what I was trying to do. Let's see. Probably the best move, the most likely to be successful move would be to hack it, like to just like duct tape it. Like the duct tape version of this is probably the easiest one to conceive of doing easily. So that's probably what I should start with. So basically what that would look like would be to just, I mean, it's, let's plan it as an iterative process. The easiest thing to do, probably the least sort of exciting in terms of like the animatronic aspect of it, but it's also certainly the best place to start, is to just like attach a microphone, a speaker, and a Raspberry Pi, just like bolted on, and then build the AI thing around that. So rather it's more like just build the AI Raspberry Pi mechanism, which should be pretty easy to do. Not local AI, just like API. So it would need a Wi-Fi connection, which is not hard to set up. And just attach it. So that way I can at least guarantee that I've got something working, because that'll be relatively straightforward to do with my current skill set. And then the more exciting thing, I think, which can happen, I think I'll probably want to do it somewhat in parallel, would be to start trying to figure out how to manually sort of tap in to the controllers and sort of like, well, probably I would want to be smart about it. So there's versions of this running, which is just like the standard operation of the Ultra Skelly doing its regular Halloween thing, being controlled through the app, and then just like an AI thing kind of like attached on top of that, just like bolted to it literally. And then a step beyond that would be having some form of manual control over the relevant mechanisms, like the motors and the lights. Probably in terms of like simplicity, it would be to, first of all, hijack the lights. That's usually pretty straightforward. And then hijack the motors, which is again also fairly straightforward. On the assumption, I mean, it looks like whatever kind of electronics you would need to run the motors, it looks all built in. So that's all like taking control of those should be a relatively straightforward, sort of like relatively simple thing to do within like that Arduino ESP32 type of space. And then the fun part, the part that I think that it starts getting really exciting, is to connect those things together. So to sort of on the one hand, you have this like AI sort of microphone speaker system, which is sort of stuffed full of prompts of the documentation and sort of like a write up about like how to act like a Skelly bot, and then just like attach that to this and then run the standard thing. Step beyond that is to have the AI thing running and have kind of like some hacked apart like manual controller thing, like running it through my own sort of like animatronic control system. And then obviously this part is the really exciting part, where if we can somehow find a way, like, because once we have those two things, then it's not hard to imagine sort of like attaching some kind of like HTTP like little like server endpoint type of control into whatever control system we build, and then have the LLM agentic loop or whatever that's driving the talking part generate commands in some way, which would be something like, like a API, like OpenAI, like structured outputs, kind of like pedantic JSON style control systems. I'm sure people have been out there sort of trying to get LLMs to control their robots. I'm also sure that it would do a pretty bad job out of the gate. But I think just in terms of like, I don't know, I feel like you could prompt something, right? Like, attaching certain types of questions and sort of evocative vibes to like moving the arms a lot, or moving the like if you say no, shake your head, or if you're saying yes, nod your head. Just like running the mouth while it's speaking, that would be relatively easy to set up. Relatively easy. I don't know. These are thoughts. Thank you for coming along with me on this journey. I think I'll do more. I'll think about what the next steps would be and do more. I guess the obvious next step that would be kind of like a streamable event would be to actually like set it up and turn it on, which I did not do, which is hilarious now that I think about it. But yeah, let's call that good. It's late enough in the day. I don't want to do this anymore. If you've been watching, thank you. If you've been chatting, sorry, I didn't see it. And have a good night.